Okay, so we have in class today we learned about isotopes, and we have some symbols that are associated with these isotopes. Remember, let's do purple. Isotopes, the definition is atoms of the same element with a different number of neutrons. All right. So basically, if they have a different number of neutrons, they're chemically very similar because they have the same number of protons, but they have a different mass. So here I have I have an example of the boron atoms that we saw in class today, where these are two different isotopes of boron. We have boron 10 and boron 11. These are two different ways to refer or symbolize two different ways to symbolize the isotopes. So on the above, up here, we have the chemical symbol, which is right here. This is the chemical symbol. So for boron, it's B. On the top is the mass number of that specific isotope, and on the bottom is the atomic number. Now, sometimes you'll see it without the atomic number. So think to yourself for a second, why can we leave out that atomic number? Why can we leave out the atomic number? That's right, because we know the chemical symbol, we know the number of protons that are there by definition, because all atoms of an element have the same number of protons. So every boron atom in the universe has 5 protons. So you'll see it written sometimes. Sometimes you don't need it because, all the time you don't need it, so sometimes you might not see it because if you're given the symbol, you know how many protons there are. So the number on top, if I can get the pen to work. All right, the number on top is the mass number of that specific isotope. So this must be included for isotope notation. So what it's saying is this atom on the left has a mass number of 10. On the right, it has a mass number of 11. So in order to find the neutrons, remember we subtract the protons from the mass. So this atom on the left has 5 neutrons. The atom on the right, mass of 11, 5 protons. So all the stuff in the nucleus has to equal 11. So if there are 5 protons, there must be 6 neutrons. Now, one of the ways that you can look at this is, so calculate the atomic mass of neon. Well, if there are 100 atoms of neon in this picture, so this is like from a neon sign. If we're actually taking a look and zooming in tons and tons and tons of times, well, what would that look like? Well, we'd have, other than the fact that they probably wouldn't be different colors, we see that in this sample of 100, we have one atom. Oops, that's probably confusing. We have one atom that is neon 21, so it has 11 neutrons to go along with the 10 protons. We have 1, 2, 3, 4, 5, 6, 7, 8, 9 that are neon 22, so it has the 10 protons but 12 neutrons, and then the remaining 90 are neon 20. So what this shows us from this picture is 90% of neon atoms have 10 protons and 10 neutrons. About 9% have the 10 protons and 12 neutrons. So if we look at the periodic table, well, we would check and we would assume that the average atomic weight of neon should be close to 20. And I'm looking right here, and I see that it's 20.18. Average mass for neon. I don't know why the pen's not working. Hold on 1 second. Okay. Average mass for neon is 20.18. So very close to 20. But not exactly 20, because you do have these 9% that are neon 22 and the 1% that's neon 21. Okay. So the average atomic mass is not the average of all the isotopes, it's the weighted average. Of all the natural occurring isotopes. Isotopes. And weighted by abundance. So percentage that they exist. And it's approximately the mass of the most common isotope. Now, isotope, incidentally, is also the name of the baseball team in The Simpsons, because Mr. Burns runs a nuclear plant. One of the things we're not going to study this year is nuclear reactions, but isotopes play a huge role in nuclear reactions, because you have to have the right isotope of an element to create nuclear fission. So his team name is the Isotopes. So the way you can think about average atomic mass, if we go back to the previous slide, well, if we look at neon, if we just took the average of 20, 21, and 22, well, that would be 21. So that average mass of neon is 21. No, you have to look at how many of each type there are. So the 90% that weigh 20, the 9% that weigh 22, and the 1% that weighs 21, you sort of average those together in a weighted manner. So this is probably closer in similarity to how you might calculate your grades, is the average by abundance or percentage. So, wrap up. How can atoms of the same element be different? Sort of similar to what we were doing before. Isotopes of an element have the same number of protons and electrons, but different numbers of neutrons. The average atomic mass of an element listed in the periodic table is the weighted average mass of the naturally occurring isotopes of that element. So the question might be, well, what about not naturally occurring isotopes? So these are the radioactive isotopes that we'll talk about in the next lesson. These are things that don't last very long. And isotopes are referred to by their mass numbers, such as carbon-12. So that differentiates between, for example, carbon-12 and carbon-14, which is used for radioactive dating to determine how old substances are.